Hey everybody, this is Larry. This is day 19 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Not much to. I've been having long intros lately. Today, not so much, except for that it's very hot. It's about 30 degrees Celsius here in New York City, or about like 90 Fahrenheit if you prefer. And I went for a run, not that long of a run, just I think 5 miles total, but I did most all of it easy except for 1 mile time trial in the and I hit my personal best for 1 mile, which is slightly under 7 minutes. So I'm very happy to actually be able to do that. But I mean, I think I was able to do it for a while, but like a lot of the time, sometimes you don't have to always prove who you are to yourself, right? Only once in a while. And I think there is something about that, to lead code too, right? Like your rating isn't who you are, your training is who you are and how good you are, right? And in that sense, I've been doing okay. And eventually your numbers will catch up to you if you're actually learning and improving. Okay. No long intro today, so let's go. 1482, minimum number of days to make M bouquets. 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 You're given an integer array boom day, an integer M, and an integer K. You want to make M bouquets to make a. Is it bouquets? Bouquet? Am I saying? Have I been saying this really? Why am I saying? I don't know. It's bouquet, right? Huh? Pronounce. Why am I saying it weird today? I don't know.
Bouquets.
Bouquet, right? Why am I saying bouquets? What am I thinking of? Bouquet. I don't know. I would say though, I was just doing my Duolingo in Espanol, so maybe I just my head is a little bit weird. Well, my head is always a little bit weird, but more a little bit weird than usual. Bouquet. Okay, to make okay, you want to let's actually do the way it's fun. You want to make M bouquet. To make a bouquet, you need K adjacent flowers from the garden. Okay, the garden consists of N flowers. The I flower bloom on the bloom day sub I, and then used in exactly one bouquet. Return to minimum of days you need to wait to make M bouquets from the garden. It's impossible to make it. Okay, return -1. What does this mean? Okay, first 3 days. Okay, that makes sense. So, one bouquet to do. The answer is 3. Okay. K adjacent flowers. What is the K adjacent? Oh, 1. Oh, this is K equals 1. That's why it doesn't matter. 3 bouquets, you have 2 flowers. Okay. So basically, you have 3 flowers. So after day 7, you have all these. So you can make Okay. So one thing that I would say is that so a naive way, or it doesn't have to be that naive, and I don't mean naive necessarily in a bad way, just that your initial naive way of thinking about it may be simulation, right? What does simulation mean for this problem? Simulation for this problem means that one at a time, more flowers will bloom and pop up. But let's say you have, for a given. So, okay, wait, let me finish that thought for a second. I think I jumped ahead a little bit. And when flowers pop up, what does that mean, right? That means that you can only make more bouquet, right? Because more flowers come up, you can make more bouquet. I mean, or equal to, monotonically increasing, right? And so that already kind of hints, right? But let's say you have this set of things, right? I think that's the other part of it, is that let's say you have this set of flowers. How do you optimally choose K is equal to 3 in this case, right? Number of flowers for the bouquet. And the idea here is just greedy. You go scan from left to right, and then you just do. You have 3, so let's take it. And the reason why that works is from a little bit of an exchange argument, right? I'm not going to do like a full proof. I don't fit because I don't know. It's just way whatever. But the reason is because, for example, let's say you're going from left to right, you could take either these three or these three, right? And the reason why you always want to take this one, because you're going from left to right, is that if you don't take this one, to take this one, then now you're left with basically two cases, and this kind of you can maybe be exhaustive about it if you want to play around with it. So you either have this or this, and in a greedy kind of way, this one will always give you exactly the same as this one or more bouquets, right? Because, well, you just have more possible flowers, and that's how greedy works from left to right. So yeah, maybe there's a way you could simulate it with like, I think you could actually do this with Union Find if you really want to play around with it. The way that I kind of hint at a little bit is going to be binary search. The reason is, as I said, as more days come, more flowers bloom, and as more flowers bloom, it is going to give you more bouquets, and that's going to be a monotonically increasing function. So you can definitely binary search on that. And the other part of the puzzle is that given one day, a snapshot of a day, can we figure out how to make the optimal number of bouquets? And we just kind of did that with the greedy. But I am kind of curious about the union find solution, so I'm going to just do it twice because I don't know. I just feel, because it's just a very random dot. I think you can do it with union find if you're careful about maintaining some stuff, right? Because the idea there is that, let's say you have something like this here, you I don't know, let's say maybe this is not boomed, and then after, I don't know, day whatever, this becomes an X, then now you could add these to group 4. And really, now that you know you have a group of 4 things, it's a one-dimensional bin packing thing, right? And the same thing as I was saying, greedy works, which is to say you have 4 things, 4 consecutive things in one packet, and if case you go to 3, then you can make 1 bouquet. So I think you can actually do a union find as well, but let's play around with that. For now, let's I'm going to do binary search. Stay tuned for the union find. Okay, so then here you have boom day. So this is going to be right. So this is binary search. Maybe left should be 1. I don't know. Yeah, okay. Because the lower bound is 1, so this is left. Upper bound is right, which is the max. And I always choose my binary search to be inclusive bounds. So I could write it like this, because when left is equal to right, then now you have an inclusive bound of 1, right? Or inclusive range of 1. Maybe that's a better phrasing. But yeah. And then now we say if good is equal to mid, that means that if mid is possible to get k, oh no, not k, m, if mid days is possible to get m bouquets, then we want to try fewer days, right? So this is how we try fewer days. If it is not, then we need more days, so we we raise the lower bound. And that's pretty much the idea. And here you have to implement the good function, of course. You have a target. And then here, as we said, we're just going to be greedy, right? So current is equal to 0. And here maybe the way that I would also like to I don't know, this is just a sentinel trick, which is that the last flower will never boom. So we just append an infinity value to it, right? So that I'll show why in a second. It's not really that big of a deal, to be honest. But yeah, so current is equal to the current streak, streak, and then maybe how many flowers we can make. So count is equal to 0, something like this. And then we can return count is greater than equal to m, right? So then now if x is, if the day is greater than or equal to target, then we increment the streak. And then now else current is equal to 0, right? And there are two ways you can do it. You can do it where current is equal to 0, or you could just do it after every flower, which is that if current is greater than or equal to k, then we subtract k. I don't know why I write it like this. You could probably just set it to 0 if it's equal to k, but I don't know. And count is increment by 1, right? And you could also do it the other way, as I said. When you reset it to 0, you can just divide it by k as well. And this sentinel value will ensure that happens. So that's good. All right, so let's give it a quick run. And all wrong. Well, we definitely forgot to handle the -1 case. So, max number of days. So if all the flowers bloom, yeah, okay. But I think I actually want this to be max +1 so that it differentiates between when all the flowers bloom and all the flowers bloom +1. So then now, if left is equal to max of, do I have to update this because we added an append, so that's not going to be, so maybe, yeah, max is equal to max of bloom day. Right is going to be max +1. And if left is equal to max +1, then we return -1. But why am I getting 1s on the other ones? Did I mess it up? If x is greater than or equal to target, I am obviously doing something wrong. And I've been just really disappointed in myself recently with respect to how poorly I've been been programming. I've just been very sloppy. I don't know why. Maybe it's the running, maybe it's exercising. I don't know. But yeah, count. Did I mess this up? I think this sign is just wrong. So if x, oh yeah. I got the signs wrong. Because x is the day that it blooms, so this is greater than it is after, right? So we actually want it the other way. Whoops. All right, there we go. Let's give a quick submit. Hopefully I didn't make a silly mistake. I've been making a lot of silly mistakes lately. Okay, that was an easy fix. So 1541 day streak. What is the complexity here, right? Let's say right is going to be max +1. There are a couple of things you can do, but max +1, and we do a binary search on this, right? So this is going to be log, let's say m is the max of the bloom day, then it's going to be log of m, and of course for this number of iterations, and each of these will be a linear thing, so it's going to be n log m. You can also, the good thing about this is that it's O of n, right? So O of n log m. So okay, let me write it out. Right. So this is O of n log m time O of one space, right? I mean, maybe excuse this little thing, but O of one space. But you can actually, so log m is going to be, up to 32 in this case because of the bloom day. But you can actually more strictly bound this to O of n log n by coordinate compression, right? Keeping in mind that here, for example, you have 7s and 12s, but the 7 and 12s don't matter. You just need to know the order. So if you renumber everything so that the 7 is equal to 1, 12 is equal to 2, then in this case, you can do a binary search in log n time because there are at most n distinct numbers. And if you do the coordinate compression or or renormalization or whatever you want to call it, remapping, then this is going to be n log n time, but it will take all of n space as a result of, you have to re-index all everything so it goes to 0 to 1, right? So that's the complexity here. Okay, so this is okay Gucci, right? So binary search. As I said, I do want to play around with Union Find. So yeah, if you want to watch the Union Find version, definitely stay tuned. double check a sec. Okay, yeah. Yeah, okay. Right. So then here, all right, let's bang out the union find or disjoint set union. I'm not gonna go over that much in detail what union find in or disjoint set union is for this video, but definitely something that is fundamental and probably should be known. But I'm just gonna write it out. Right? Parents is you go to yeah. So I'm just gonna bang this out the union find code, right? And I'm not gonna lie, I'm not really going over this that much because hopefully the expectation is that you you know are familiar with it, right? But I have to do a little bit better because I think I have to actually do sizes, right? Okay, so this is for path compression. This is probably usually good enough, but we actually also need to add sizes. So yeah. We don't have to care that much, but and that's really it. I mean, it's not theoretically optimal, but it is close enough, really. Yeah, and then now the other thing that we have to do is that we have to boom them in order, kind of, right? I mean, it doesn't have to be in a strict order, but obviously the one comes before the two, etc. So then now we go like for index x in enumerate boom day, right? And maybe we'll call them events because I like calling everything events. We want to sort by the value, and then we have the index, and then events dot which we call it. So I don't know why I was looking for that. I'm just really not quite good Gucci. Okay, and then now we have for x. X actually doesn't matter, and then we have index in events, and then now the idea here is that maybe we also do boomed is you go to force times n, right? And then now this is just saying that okay, the index is booming, and then now boomed of index is equal to true, and then if I was just debating whether I should write as a for loop. I don't know, maybe right. So if the index before also boom, then now we can merge them together, right? So then now we want to unify index -1, right? Or and then you do the same for index +1. Okay, but now we have to be a little bit careful, which is that okay, I mean this is we have to do the count, right? So this is the number of bouquets that we're able to make, and then maybe now we have to calculate what is the delta of this effect, right? So the delta of this effect is going to be the size of the previous left and the previous right, and then so there are a couple of ways you can do it probably, but what I'm going to do is just subtract out what the previous numbers were and then add back in the current numbers, right? So for example here, yeah, so if this is the case, then we want to remove that from, so we subtract it from the size of, in theory, index -1, but actually we want the parent of that, right? So this gives us the size of the union find group, and the same thing for this one, right? And then now, after the union is done, then yeah, okay. Oh, I think I have to do the subtraction before. That's why I was like, something looks a little bit funky. Because after we union it, this changes the answer, right? But then now, after we union it, then now we know that index is going to be the new size. So then we could do count. We add it by the size of this. This isn't quite right, actually. I'm a little bit sloppy. But this is the size, right? But the size divided by m, right? Round down because we need the same greedy way that we talked about. And then now, if count is greater than or equal to, this divided by I mixed up the m's and the k's. So this is actually divided by k. Maybe I should see. This is the benefit of having a for loop, is that you only make changes in one place instead of like 3 places like I keep on doing. I don't know. I like the symmetry about this as well a little bit, which is why I went for it. Especially 2 is like one of those things where you can make some argument about symmetry. I don't know. Maybe I do regret that. Not like a huge regret, but like I'm like, maybe that could have been better. But in any case, if count is greater than you go down, then we can return the time, right? So actually, we do need the time because that's the thing that we have to index on. And then else, we just return -1 because every flower has bloomed. So okay, let's give it a quick spin. Hopefully this is still right. Let's give it a submit. Hopefully I didn't miss a case. It does appear to be slower, or at least higher constant or whatever, but it still looks pretty Gucci, so I'm pretty happy about that. What is the complexity, right? It probably is going to be dominated by the event sorting, so that's going to be n log n. This is O of n, a loop O of n, and everything is, let's just say if we implemented union find perfectly, it'll be O of 1-ish, constant-ish. I know, reverse argument thing, but let's just say O of 1-ish, so this is going to be O of n, but that means that it's going to be dominated in either case, even with argument function, or inverse argument function. This is going to be n log n. So this is the n log n time, O of n space, because we need it for the events, and also the union find. But yeah, I don't know which one I prefer. I think both of them are very versatile in terms of, I mean, for this problem, obviously it doesn't really matter, but I'm just thinking about like, okay, if you add another constraint, which one is more likely to be more useful? I don't know, because I think both kind of matters. But yeah, that's all I have for this one. Let me know what you think. Solved it twice. Yeah, just let me show you the code and in the bottom. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. I'll see y'all later and take care. Bye bye.